Okay, today we're going to talk about significant figures. This is often a source of frustration for many students, so I'd like to start off by giving you an example. Suppose you get on a scale and it says that you weigh 78.2 kilograms. This instrument is only accurate to 1/10 of a kilogram, and this means that you really may have weighed anywhere from, say, 78.15 kilograms, or maybe you weighed 78.16, 78.17, all the way up to 78.24 kilograms. All of these would round off to 78.2. And this instrument is not capable of telling us whether we just ate a piece of candy that weighed 0.02 of a kilogram. You would weigh, according to this, you would weigh the same before and after. And the accuracy of this instrument limits how much information it can give you about what your weight actually is. So if you get on the scale and you weighed 78.2 kilograms, and your friend gets on the scale and weighs 65.5 kilograms, and somebody else gets on the scale and they weigh 62.9 kilograms, and you would like to know the average, then what you would have to do is to add up these three and divide by 3. And let's see what the result is. 78.2 plus 65.5 equals plus 62.9 equals, and we want to divide that by 3. And that gives us 68.866666667. So you might be very tempted to write down exactly what your calculator just said on exams. But we have to go back to our original measurement. Look at this. There are only 3 digits here. And each of our measurements, each of the 3 people that got on there, would get their weight to 3 significant digits. When you give the average, you can't say that suddenly this scale is remarkably accurate to a microgram here. That's just not realistic. What we would have to do is to say that no, in fact, the average is 68.9. We have to round it to the same number of digits that we have here. These other digits, we would say those are insignificant because this is pure fiction made up by just dividing by 3. So don't believe everything your calculator says. You have to interpret what your calculator says and put the right number of significant digits on there. Okay. So how do we determine the significant digits? What makes a digit significant or not? If you have a number, if you report a number like 4.0 times 10 to the minus 3, here are the things that are significant. So this is significant, this is significant, this is not significant. So what that means is that, I'll let you guess, this one has 2 significant digits. That are significant are just these 2. These are the only ones that are significant. These 3 zeros and this one, so these 3 ahead of the 2 and these other 4 are all insignificant. So this one has 2 significant digits also. This is how your homework deals with significant digits. So for this answer, I actually entered 7.278, and it only wanted 3 significant digits because it gives you the information in the problem with different numbers of significant digits. Here we see 4 significant digits, because remember, these guys are not significant. If it's 10 to the 47, it doesn't matter. It's not significant. These are what your measurement actually is. So over here, we get 1 mile is 5,280 feet. That's not 5,280.00000. It's just 3 significant digits. These 3, but not that 0, are significant. That limits the overall accuracy of your answer, that you can only give your answer to 3 significant digits. And keep in mind that when we talk about significant digits, we don't mean decimal places. I could write 7.28 miles in terms of feet, and I can only give it to 3 significant digits. Let's take a look at that really quick, what that would be. 7.28, so 7.28 times 5,280, it's going to give me a lot more than 3 significant digits, but we have to round it off because we only gave it 3 digits. So this would rightfully be rounded off to 38,400. So the 3 and the 8 and the 4 are significant, and then the rest are not. It just means that they're fiction. It's something your calculator essentially made up because it interpreted what you said as 7.28000000. So when you're on the online homework and you see this, it doesn't mean that you did something wrong. It's giving you feedback. It's a good thing when you get this purple box. It's giving you the number that you really should use later in the problems.